A skill you need to have to be successful in chemistry is the ability to measure things. So how do we measure things? What do we use? So science uses the SI units, which stands for System International Units, for measurement. This is all based off of the metric system. We recognize 5 types of measurement: length, mass, volume, time, and temperature. And each of those has a metric unit that we use to measure it. Length, we measure in meters, abbreviated lowercase m. Mass, we measure grams, abbreviated lowercase g. In volume, we measure liters, abbreviated uppercase L. In time, we measure seconds, abbreviated with an S. And temperature can be in either Celsius or Kelvin. We will be using Celsius most often, but Kelvin will come into play later this school year. So you have to think about, when you're given a number, you have to think about what that means it was measured. So for example, if I told you I was 1.6 meters tall, what am I telling you about myself? I'm telling you my length, because meters is our length measurement. If I say that I'm buying a 2 liter of Coke at the store, what is being measured about the Coke? The volume of the Coke is being measured. That is the volume of Coke you have purchased. And if I take 0.025 grams of Benadryl during the spring for my allergies, what if I actually measured about the amount of Benadryl I'm taking? I have measured the mass of the Benadryl. So we have different measurement tools to measure different things. For example, if we're measuring length, you're going to use a ruler, probably already familiar with one of those. If you're going to measure temperature, you're going to use a thermometer. If you're going to measure volume, you're going to use a graduated cylinder, which you're familiar with from doing your lab equipment activity. If you're measuring time, you're going to use a stopwatch or a clock. And if you're going to measure mass, you're going to use a balance, which you're also familiar with from that lab activity. Now, when it comes to taking measurements, regardless of the tool you use, 2 things are important, and that is accuracy and precision. Accuracy is the ability to get the correct measurement, the real number. Meanwhile, precision is the ability to do the same thing repeatedly. We want our measurements to be accurate and precise. Like this bullseye here, they hit the center every time. It's accurate because we want to hit the center, but it's precise because they were able to do it over and over again. Meanwhile, this over here is precise. They kept hitting the same location, but it's not accurate because we wanted to hit the center. This would be dangerous in a lab because you kept getting the same answer over and over, making you think you did a good job, but you really didn't. Accurate but not precise can also be tricky because we got the correct number sometimes and we're hitting the same general area but not in the actual same area, which means sometimes you get the right answer but sometimes you don't. And obviously we do not want neither accurate nor precise because that just means you're all over the place. You probably don't know what you're doing. Now in chemistry, you have to make sure you're reading your tools correctly. And now I know most of you out there are thinking, Miss Hinkson, I know how to read a ruler. I got this. But most students actually don't, so pay attention. So on your screen right now, you have a ruler, and let's say we're trying to measure that orange line right there. So I know that that line goes past the 2, and it does not make it to the 3. So I am certain of that too. I know that it goes past the 1, 2, 3, 4, 5, 6, 7, and doesn't make it to the 8, so I am certain of the 0.7. However, that third digit, and this is what students often forget, is going to be estimated. I don't have a line to fully gauge it by, so I'm just going to make a guess. And maybe I think it's about halfway through, so I put it as a 0.05. Maybe I think it's a little over halfway, so it's a 0.06 or 7. So that means when I'm reporting my length, maybe I report it as a 2.75 centimeter line. But maybe I report it as a 2.74 centimeter line, or maybe I report it as a 2.76 centimeter line. All those answers would be counted as correct because that last digit is estimated and it's within a realm of reason. Let's try it again. This time our orange line has gotten bigger, but let's follow our same steps. My first digit is known. I can see that it is on the 3. Doesn't make it to the 4, definitely past the 2. And I can also see it doesn't make it to the 1. So I know it is a 0.0. Now my third digit is still going to be estimated. I think that is dead on the line, so I estimate that to be 3.00 centimeters. Maybe you estimated it slightly different, and that's okay. Our next tool that you're probably less familiar with reading is our buddy, the graduated cylinder. Reading graduated cylinders is different from reading rulers. That's because liquid inside a graduated cylinder is going to create a curve that looks like you can see right here. That's called the meniscus. And we read graduated cylinders by reading from the bottom of the curve or the bottom of the meniscus. It is best to get at eye level with the meniscus, so you're not looking above or not looking up from below. It gets you the most accurate measurement. So let's look at this graduated cylinder. What is the volume of this liquid? So I am certain it is at least 60 and is not 70. So then I go 61, 62, 63, 64, 65, 66, 67. Does not go to 68 because remember we're reading from the bottom of the curve, not the top of the curve. Then I have to estimate, and I think it's right on the money, so I put it down as 67.0 milliliters. Maybe you estimated that last digit slightly differently, and that's okay. Let's do some more practice. I want you to pause your video and read these graduated cylinders. Come back once you have answers for each of them. Our first graduated cylinder, you should have gotten in the neighborhood of 63.5 milliliters. You had to have had the 63. If you got a 0.4 or 0.6, that would be great too. Our next one is 2.66 milliliters. And our last one is 24.0 milliliters. Once again, that last digit is always estimated. So maybe your answer was slightly different, but it should have been close. So the last thing we need to talk about is metric prefixes. You may have noticed in the previous slides I was talking about centimeters and milliliters, and you were wondering where those came from. Those are our metric prefixes. I like to remember the metric prefixes by the saying, King Henry died unusually drinking chocolate milk. And that stands for kilo, hecto, deca, unit, deci, centi, milli. The metric prefixes you're going to be responsible for knowing. Unit stands for our base unit, those ones you've already learned about, meters, liters, grams. And then we can go bigger with these prefixes, and we can make things smaller with these prefixes. Now, how do you know which prefix to use? We are going to use the metric prefix that is best suited for what we are measuring. So you're going to use the metric prefix that makes the most sense in a given situation. For example, you would never say that a skyscraper was 350,000 millimeters tall. That sounds ridiculous. But saying that it's 350 meters or 35 decameters tall sounds perfectly good. Similarly, it would sound weird to say that a cat is 5,000 grams when you could say that that cat is 5 kilograms. It's a measurement that makes much more sense. On the other hand, if we're measuring a film strip, meters is way too big, but saying 35 millimeters sounds perfectly normal. So the prefix you use depends on the situation. Now you can convert from one metric prefix to another super simply. There are just 4 steps. First, you're going to determine the prefix you are starting with. Then you're going to determine the prefix you are converting to, and you are going to count how many spaces you move when you go from step 1 to step 2. And you're going to move the decimal over that many spaces in the same direction. Let's take a look at what I mean. You are asked to convert 3.4 kiloliters to decaliters. So I find my kiloliters, K, king, and that's where I'm going to start. And I'm going to decaliters, which is that uppercase D, and that's where I'm going to finish. And I know that it takes me 1 2 steps to get there. So I'm going to move my decimal, this decimal right here, 2 spaces, and I'm going to move them to the right because that's the direction my arrows went. Which means 3.4 kiloliters is actually 340.0 deciliters. See, that's not so bad. Now keep going to get some more practice.